I'm Shalini, we working as assistant professor of physics. In this video, I will discuss the topic for the session 27 for first semester B.Sc under the chapter rigid bodies. The topic of this session is moment of inertia of a thin uniform rod. So before calculating the moment of inertia for the thin uniform rod, we have to note the definition for moment of inertia and the radius of gyration. In the previous video, I explained in detail what is the moment of inertia and also the radius of gyration. Here just I will give you the definition for moment of inertia and the radius of gyration. So what is the moment of inertia? Now consider a rigid body having a mass capital M and the mass of the body is concentrated at the point C, which is at a distance of k from the axis of rotation. Then moment of inertia of this rigid body which is rotating about this axis is given by I is equal to mk square, where k is called as the radius of gyration. So radius of gyration, it is a distance of the point from the axis of rotation at which the entire mass of the body is assumed to be concentrated. Knowing the moment of inertia and radius of gyration, now let us calculate the moment of inertia of a thin uniform rod. So now consider a thin rod. Let AB be a thin rod having a length L and let G be the center of gravity of the rod. So let AB be the thin rod having a uniform cross section and L be the length of the rod and G is the center of gravity of the rod, and let capital M be the mass of the rod. Then let small m represent the mass per unit length of the rod. That is, small m is equal to mass capital M per unit length of the rod, that is m by L. So hence from this one, capital M can be written as equal to m into L. So capital M is equal to small m into L. This is equation number 1. Now let us calculate the moment of inertia of the thin rod about different axes. So let us consider the first axis which passes through the center of gravity of the rod and also perpendicular to the length of the rod. So we have to calculate the moment of inertia of the thin uniform rod about an axis passing through the center of gravity and perpendicular to the length of the rod. To calculate that one, let us consider a rod AB which is having a length L, and consider an axis PQ which passes through the center of gravity of the rod. Then distance from A to G is L by 2 and G to B it is L by 2. Now to calculate this one, we imagine that the whole length of the rod, it is divided into small element, that is it is cut into small pieces, and in that number of pieces consider one of the piece, that is a one of the element in it. So and I have represented that element with the red color here. So this is the one of the element which is considered, which is having a length dx and it is at a distance of x from the axis which we have chosen here. That is the axis which passes through the center of gravity and perpendicular to the length of the rod. Then first what we have to do is to calculate the moment of inertia of the entire rod about this axis. First we have to determine the moment of inertia of this one of the element about this axis. Then to calculate the total moment of inertia, we have to add the moment of inertia of all the elements which lie from end B to the up to the axis PQ. So first we have what we have to do, we have to calculate the moment of inertia of this element about this axis. To calculate the moment of inertia of this element about the axis PQ, which is equal to mass multiplied by distance square. Distance we know it is x. So we have to calculate first the mass of this element. To calculate this mass of the element, mass of the element, it is equal to m into dx, because small m is the mass per unit length. Per unit length of the rod, mass is small m, but here the element is having a length dx, hence its mass is equal to m into dx. So mass of the element is equal to m into dx. then the moment of inertia of this element about the axis PQ, it is equal to mass multiplied by distance square. That is, I dash is equal to m into mass into distance square. So m dx into x square or mx square into dx. You take this as equation number 1. Then total moment of inertia of the entire rod PQ means what we have to do is, so in the previous figure, so this is the what we have written equation 1. It is the moment of inertia of this element about the axis PQ. To calculate the total moment of inertia of the rod, we have to add the moment of inertia for all the elements which lie from B to PQ. So we have to add all the moment of inertia of all the elements to other, or otherwise we have to integrate the this equation 1 between the limits. So then total moment of inertia of the entire rod about the axis PQ is IPQ is equal to integration from minus L by 2 to plus L by 2 into mx square into dx. That is, this is nothing but I dash. Limits minus L by 2 to plus L by 2 means because we have to add the moment of inertia of only the elements which lie from center of gravity to the one extreme. So the limits will be minus L by 2 to plus L by 2. So integrate this equation. If you integrate this equation, what you will get is mass is a constant. Integration of x square dx is x cube by 3. Limits minus L by 2 to plus L by 2, which is equal to m by 3 into upper limit is L by 2 whole cube minus of the lower limit is minus L by 2 whole cube. So whole this thing will be 2 times of L by 2 whole cube. So this is whole is m by 3 into 2 times of L by 2 whole cube, which is equal to m into L cube by 12. Now this L cube can be written as equal to L into L square. So that is this is equal to ml into L square by 12. But from equation 1 we know that m into L is nothing but equal to capital M. So taking that one, so m is equal to ml, this equation can be written as equal to moment of inertia of the rod about an axis PQ. It is equal to capital M into L square by 12. So this is the expression for moment of inertia of a thin uniform rod about an axis passing through the center of gravity and perpendicular to the length. Now what is the value of radius of gyration means? Compare this equation with the general equation, that is mk square. I is equal to mk square. If we compare this equation with the m into k square. So k square value we will get L square by 12. Hence the k value is equal to radius of gyration, k is equal to L by 2 root 3. So this is about the moment of inertia of the thin rod about an axis passing through the center of gravity and perpendicular to its length. Now let us consider the another axis. We have to calculate the moment of inertia of the same rod about an axis passing through one end of the rod and perpendicular to its length. So now consider a rod AB, same rod having the same length, having a uniform cross section. And now the axis chosen is the P dash Q dash, which passes through one end of the rod and it is perpendicular to the length of the rod. Again here G is the center of gravity of the rod. Again, to calculate this one, again imagine that the whole rod is divided into small elements and consider one of the element in it and calculate initially the moment of inertia of the one of the element. So if we calculate the moment of inertia of one of the element, what we will get is m into x, small m into x square. So which we have represented that in equation number 2, that is the moment of inertia of the element about the axis p dash q dash is equal to mx squared, that is given by equation number 2. Now to calculate the total moment of inertia of the entire rod, we have to integrate the equation 1, that is the 2 equation with respect to particular limits. So since here the axis lies at the one extreme end, we have to add the elements which lie from one extreme end to the other extreme end. So the limits will be 0 to from 0 to L. So hence the moment of inertia of the rod about an axis P dash Q dash is equal to integration from 0 to L mx square into dx. So hence if we integrate that one, so m is constant, m into 0 to L x square dx, or if you integrate x square dx, it will be x cube by 3 between the limit 0 and L. Substitute the limits. If you substitute the limits, you will get m l cube by 3. Lower limit is 0, so hence you will get m l cube by 3. Again here L cube can be written as L into L square. Yeah, so the bracket term again m into L is nothing but equal to ml. Capital M, mass of the thin rod. So substituting this one, finally what you will get is the moment of inertia about the axis passing through one end of the rod and perpendicular to its length is given by I p dash q dash is equal to m l capital M into L square by 3. So this is the expression for moment of inertia of the thin rod about an axis passing through one end of the rod and perpendicular to its length. Again compare this equation with the general equation mk square, then radius of gyration k is equal to L by rho 3. So this is all about the moment of inertia of the thin uniform rod. So the authors of the books which we have referred are Properties of Matter by D.S. Mathur, Unified Physics by Dr. S.L. Gupta and Sanjeev Gupta, and Mechanics by D.S. Mathur. Thank you.